Well, you see, there is a moment when you look up at the night sky and you catch a faint blur drifting across the darkness, and you cannot help but wonder, what is that little ghost of light, and why has it drawn the attention of so many people back here on Earth? And perhaps the more curious question is this: why would a smudged dot captured by billion-dollar spacecraft stir just as much debate as the beautifully processed images taken by amateur astronomers in their own backyards? You know, it makes you think. It makes you pause. If a distant traveler like the Interstellar Comet 3I Atlas can ignite such arguments, then maybe the real mystery is not just the object itself, but also the way we humans try to read meaning in the thin, trembling photons drifting toward us from across the void. And that is the thing. Well, that is the thing. NASA holds a press briefing, calmly confirming that this visitor from beyond our solar system is indeed real. A genuine comet wandering through our celestial neighborhood. Meanwhile, the internet buzzes with doubts. The tail looks odd. The plasma seems too strong. The photos do not quite match expectations. So what are we actually looking at? Are we misreading the data, or letting our imagination sprint ahead of the evidence? I suppose the heart of the question is simple yet profound. When we ask, is this real? Are we talking about the physics? Or about our own willingness to see the universe as it truly is? Whether it exists at all in the way we think it does. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. Well, you see, when we talk about the so-called blurry images from NASA, we often imagine that something must have gone wrong, as if the universe owed us a pristine postcard every time a spacecraft opened its eyes. But that assumption hides a deeper misunderstanding about how we look at the cosmos. The cosmos is not a stage lit for our convenience. It is a vast ocean where light travels across unimaginable distances, bending through dust, scattering off ice, fading into silence. And when NASA shows us what appears to be a soft, shapeless glow instead of the dramatic tail captured by amateur telescopes, it's not because their machines are weak. It's because they are designed for something different. Not just beauty, but truth. Not just a picture, but a measurement. We sometimes forget that. And that's the thing. When James Webb or Hubble points their mirrors toward an interstellar comet like 3I Atlas, they are not painting. They are counting photons, one by one, like listening for faint footsteps in a distant corridor. So the images look messy because reality at that distance is messy. There is dust, there is coma, there is the glowing fog of gas escaping from ice older than our Sunday. And, the instruments do not sharpen that fog. They analyze it. They take its spectrum, rip it into colors we will never see with human eyes, and use those colors to tell us what the object is made of. Carbon dioxide, water, strange ratios of metals, a chemistry that whispers of another star system long forgotten. That is what these images are really for. You know, I suppose if you put yourself in the position of an amateur astronomer on Earth, capturing a long, graceful tail with a telescope costing a fraction of a space mission, it feels odd. The amateur images look alive, almost artistic. You see the jets curling outward. You see the tail bending in the wind of the Sunday. You see a creature. But NASA's view is quieter, almost clinical. And that might lead some people to wonder whether the agency is hiding something or perhaps missing something that everyone else sees. Yet, yet, the truth is exactly the opposite. The spacecraft are showing us what the amateur telescopes cannot. The numbers, the structure beneath the beauty, the physics beneath the glow. Well, let me try an image for you. Imagine you are standing in a foggy room. The fog is thick, silver, shimmering in a faint beam of light. To your eyes, it is beautiful, mysterious. But if you tried to photograph it with a camera meant for medical imaging, the picture would look strange, blotchy, almost unreadable. Not because the fog is different, but because the tool is asking a different question. Not what does it look like, but what is it made of? Science does that. It replaces the painting with the map, the feeling with the measurement, and even though we love the painting, it is the map that tells us how the world really works. Take the Mars Reconnaissance Orbiter, for example. From its high-rise camera, each pixel covering around 20 kilometers when pointed at a distant object like 3-eye Atlas, the comet becomes a fuzzy dot with a bright halo. That halo is the coma, a cloud so large it swallows fine detail. It's not the instrument failing, it's the universe overwhelming the instrument with sheer scale. The comet is shedding dust and vapor into a sphere tens of thousands of kilometers across. And when that sphere fills the pixel grid, the nucleus, the tiny solid core at the center disappears. It's like trying to find a single grain of sand inside a lighthouse beam. Light overwhelms shape. Maven goes even further. It does not take pictures at all. It listens to ultraviolet whispers, measuring the wiggles in spectra that tell us how hydrogen is flowing away from the comet. And, well, those wiggles are far more scientifically valuable than any close-up shot could ever be. They reveal how much water is evaporating, how strong the sun's ultraviolet light is stripping the comet's gases, how the plasma tail grows and breaks under the pressure of the solar wind. These are the things that let us say, yes, this is a natural object, breathing like other comets breathe. And then we have other spacecraft, Lucy, Soho, Punch, each built for tasks that are not about taking portraits, but about watching the dance between sun and dust, between star and wanderer. So when they pick up 3-eye Atlas drifting through their fields of view, the comet appears as a pale shape, often faint, sometimes distorted, because their cameras are tuned for brightness near the sun, not delicate tails in the darkness. It's not a flaw, it's the mission itself. And yet, there is something touching about the contrast. On Earth, an amateur astronomer with a modest telescope points it at the sky and creates an image glowing with detail, the jets erupting, the tail arching away as though drawn by a soft blue brush. It's a kind of intimacy, a closeness that comes from looking at the right brightness with the right expectation. NASA's view is less intimate, but more revealing. It pulls the object apart. It shows us composition, temperature, motion. It tells us how fast the comet is shedding its ancient ices that formed around another star long before the Earth cooled. And when you think about that, the blur becomes a doorway rather than a flaw. Perhaps the confusion lies in the way we think about clarity. We grow older, clocks tick, our eyes chase sharper images because we believe sharpness is truth. But in astronomy, clarity is sometimes hidden inside the blur. The blur carries the information. The coma hides secrets in its structure. The way the haze thickens and dims tells us how active the nucleus is. The way the tail fades toward the sun shows how radiation pressure is shaping dust. The way the jets bend tells us the comet is rotating. Every soft edge is a story. And when NASA compares the shapes of these blurs across time, it can measure the nucleus's spin. When it studies the spectrum, it can tell what ices came from the comet's birthplace. When it models the coma, it can even guess at how much material is left beneath the surface. These are the kinds of things no pretty picture can offer. They are the invisible layers of reality that only emerge when you trade aesthetics for data. So when people ask why the amateur images look better, the answer is simple. They're not better, they're different. They capture what the human eye craves: form, contrast, motion. NASA captures what the scientific mind needs: structure, chemistry, ancient memory. One shows the dance, the other shows the dancer's bones. And this difference becomes especially beautiful when you realize the two must be combined. The amateurs show us what the comet looks like tonight, under our sky, glowing just above the horizon. NASA shows us what it truly is, across time, across energy, across physics. Not just a rocky snowball, but a fossil drifting through space. Not just a visitor, but a witness, carrying stories from a star we will never see. And that idea leads us somewhere important. Because if the images look strange, if the measurements seem abstract, if the haze feels too vague to trust, it's worth remembering that everything we know about the early universe came from blurs far fainter than this. The cosmic microwave background, the first light after the birth of everything, is also a blur. But it's a blur that taught us the age, the shape, the destiny of the cosmos. Sometimes the faintest signals carry the greatest truths. Thinking about that brings us back to 3i Atlas. Here is an object from another star, arriving in our skies for a brief moment. NASA's images may not satisfy our desire for crisp beauty, but they satisfy something more essential: the need to know. To know what this thing is, to know where it came from, to know why its gas ratios differ from those of comets born in our solar nursery. And these measurements, soft and blurred though they appear, are the only doorway we have into that distant system. It's not about making a perfect picture. It's about tracing the fingerprints of a world that existed long before ours. A world whose star may have dimmed or died. A world whose dust may have scattered into the dark. The comet is a survivor, and the science hidden within the blur is the memory of that survival. And so when we look at those images and wonder why they seem bad, we might instead ask why we expect clarity from something so ancient, so distant, so fragile. Perhaps the blur is exactly what we should see. Perhaps the universe reveals itself most honestly when it refuses to sharpen for us. And that thought gently opens the door to another question, one that guides us naturally toward the next part of our journey. If NASA gives us the numbers and the deep truth, what role do the people back on Earth play? What happens when the sky belongs not just to the spacecraft, but to everyone who looks up at night and wonders? Well, picking up from that quiet doorway we just opened, you see there is something almost tender about the way the sky becomes a shared place when an object like 3i Atlas drifts through it. And it's in that shared space that the story of NASA and the amateur astronomers unfolds, not as a competition, but as a kind of duet. Because the sky, the sky has never truly belonged to institutions alone. It belongs to anyone willing to look up. And in the days after perihelion, as 3i Atlas curved away from the sun, that truth became clearer than ever, And When the first amateur images appeared around the 8th, the 9th, the 10th of November, they had a kind of vibrancy that felt almost intimate. Long, bright tails stretching across the frame, jets bursting in directions that seemed almost rebellious, and even a jet pointing back toward the sun itself. And we saw the same patterns emerging from different parts of the world, night after night, telescope after telescope. That consistency carried its own quiet authority. It said, it is really there. This is what it looks like in our sky right now. And yet, when NASA released their own material, the conversation shifted again. Their data wasn't flashy. It wasn't sculpted. It wasn't shaped by the human eye's desire for contrast. It was slow, careful, and wrapped in the weight of scientific filtering. Their images needed processing, modeling, color reconstruction. They came later, and they required patience. And, well, that delay can make people uneasy, especially in a time when the world expects everything at once. So here we stand between two worlds. One world is immediate, emotional, because the amateur astronomer simply points their camera at the sky, gathers photons, and lets the comet reveal itself as a creature of light. The other world is methodical, deliberate, because NASA does not just gather photons, it interrogates them, it pulls them apart, it anchors them in physics. And sometimes that difference creates tension, not because the worlds disagree, but because each world sees with a different set of eyes. But if you step back a little, you notice something beautiful. Modern astronomy is not just telescopes on mountains or spacecraft orbiting Mars. It's not just data streams flowing into laboratories or pictures circulating through social networks. It's not one group looking up while the other looks down at readouts. It's both. It's all of it. It's the blending of the immediate human experience with the deep, time-consuming patience of science. And that blending has never been visible quite like it was with 3i Atlas. Let me paint this scene for you. Imagine a quiet hillside somewhere in the world, under the November sky. An amateur astronomer, someone who has stayed up far too late and burned through countless cold nights, waiting for something extraordinary, aligns their telescope, checks their mount, and opens the shutter. What they see on the screen is alive. The jets spiraling, the tail flicking away from the sun, the faint electric edge of plasma carved by solar wind. They post it online. Someone halfway across the world sees it, takes their own picture the next night, and the same patterns appear, the same tail, the same jet, the same odd shapes. And it becomes a chorus, many eyes seeing the same truth. Meanwhile, NASA's spacecraft orbit in silence, each doing its job. Lucy looking primarily at solar wind structures, SOHO watching for coronal mass ejections, Punch imaging faint features in the outer solar atmosphere. None of these spacecraft are there to take portraits of a comet. Not just that, but also because they are built for something broader, for studying the sun itself. So when 3i Atlas glides through their fields of view, it appears small, faint, an intruder in the middle of a much larger science mission. And the images show that difference. They show the comet as a scientific artifact rather than a visual phenomenon. Yet these two perspectives, contrasting as they are, begin to interlock. The amateur images reveal the morphology of the tail on a daily basis, the length, the kinks, the subtle curves, the sudden bends after solar wind events. NASA's ultraviolet spectra reveal how much water is escaping. The near-infrared results reveal the strange carbon dioxide to water ratio. The modeling explains why the tail is shaped the way it is. And slowly, these layers mesh into a single picture. It becomes obvious that we cannot understand the comet without both worlds, the painting and the map, the beauty and the measurement. And I suppose there's something philosophically rich in that union. We grow older, clocks tick, and the universe shows us again and again that truth is rarely found in a single perspective, not just in the laboratory, not just in the backyard. It lives between them. It breathes in the collaboration, even when the collaborators never speak to one another directly. The amateur community, scattered across continents, acts as the comet's heartbeat monitor. They catch changes first. They notice the tail behaving strangely after a solar storm. They observe new jets as the nucleus rotates. They see when the coma brightens suddenly. And because their observations come daily, sometimes hourly, they store time in a way spacecraft cannot. That temporal detail is priceless. NASA, however, provides the skeleton beneath the visible skin. They determine the nucleus size. They detect the unusual chemical signatures. They tell us the water production rate, the rotation period, the mass loss. And these facts anchor the amateur images in physical reality rather than speculation. Together they build something that neither could create alone. Think about that for a moment. The sky becomes fully real only when both kinds of observers are watching, the professional and the personal, the numbers and the wonder. It's not a competition, it's a conversation, a quiet conversation between Earth and space, between technology and human curiosity, And I think what makes this particularly moving is the way it reveals the democratization of astronomy in the age of the internet. A century ago, a discovery like this would have belonged entirely to institutions. But today, you have people in small towns with modest telescopes contributing real scientific insight, sometimes even noticing morphological changes before the large organizations process their data. So the sky becomes a place where everyone can participate in truth-making, not just watching, but contributing. And that participation is crucial, especially when the object in question is so unusual. An interstellar comet is a rare opportunity. We have only ever seen 3 such visitors. To understand them, we need every angle, every wavelength, every night of observation. And because 3i Atlas changed shape from one night to another, the amateur network became a distributed system of eyes, capturing the rapid evolution of dust and plasma. It's almost like listening to an orchestra. One instrument alone cannot play the whole piece. NASA provides the deep bass notes, the structure, the steady pulse. The amateurs provide the shimmering violin lines, shifting, alive, textured. And, the comet itself is the melody that flows through both. But there is something else too, something quieter, something human. When people post their observations, they often share more than data. They share emotion, awe, confusion, excitement. They comment on the shape of the jet, the unexpected turn of the tail, the eerie feeling of watching something that came from another star. NASA's reports, in contrast, are formal, precise, restrained. And this duality creates a fuller picture of the object, one part scientific, one part poetic. And you see, that combination is fitting for an interstellar traveler, because such an object does not just belong to science, it belongs to imagination, to curiosity, to that ancient instinct to track lights moving across the sky. Now, if we step back again and look at the full arc of observations in November, something fascinating emerges. Despite differences in technique, both communities saw the same broad features: the long dust tail bending away from sunlight, the plasma tail behaving unpredictably, the jets flickering from the nucleus. That consistency, um, uh, that synchronicity, strengthens our confidence in understanding the object as it truly is. It shows that reality is stable even when interpretations differ. And so the world of NASA and the world of amateur astronomy merge into a single fabric woven from both beauty and physics. The comet becomes a shared object, not owned by anyone, but embraced by everyone. And through that embrace, we see how modern science actually works, not alone in a lab and not alone under a backyard sky, but in the interplay of both. And that interplay leads us to something even stranger, something that emerges when you stop looking at the comet as a photograph and start looking at it as a physical body shaped by invisible forces. Because once we understand how the human observers see it, the next question becomes irresistible. Why does it behave the way it does? Why do the tails twist and break? Why does the plasma shimmer and lurch? Why do the jets point both toward and away from the sun? Questions that, well, that gently carry us toward the next mystery waiting on the horizon. Well, picking up from that moment of wondering why the jets twist and why the tails bend, you see, we now step into a stranger territory, a territory where dust and light and charged particles begin to behave like dancers in a storm. And it's here, right here in this invisible battlefield around the comet, that the story becomes wilder than people expect. Because when you hear someone say the tail broke, or the plasma flashed, or the jet suddenly pointed the wrong way, it might sound like fantasy. But it's not fantasy at all. It's physics. Wild, untamed physics. And that is what makes it so beautiful. One of the first things we forget is that once dust and gas float freely in sunlight, they almost never behave gently. Not just dust drifting in a vacuum, but dust charged, dust electrified, dust pushed by photons that have crossed millions of kilometers just to strike it. And when sunlight ionizes gas, when it kicks electrons off atoms, it creates plasma. And plasma is not a polite substance. It bends and flexes and jerks under the influence of magnetic fields threading through the solar wind. So when 3I Atlas released its water, its carbon dioxide, its strange mixture of ancient ices, those ices turned into jets of gas rushing into space. And those gases, once ionized, became part of the solar wind's playground. And the solar wind is fast, hundreds of kilometers per second fast. It does not negotiate. It simply sweeps things away, sometimes in straight lines, sometimes in curls of magnetic turbulence. That's why we saw two tails, the dusty, heavy, golden one curving like a river, and the thin, electric blue plasma tail pointing almost perfectly away from the Sunday. But well, here's the part that feels almost magical. The two tails can disagree with each other. Dust listens to light. Plasma listens to magnetism. And those two forces rarely point in the same direction. It explains why one jet seemed to face the sun itself in some amateur images. It explains why the coma puffed outward like a glowing balloon on certain nights. It explains why, when a coronal mass ejection, a massive eruption from the sun washed over the comet, the plasma tail appeared to snap, to sever, to drift away as though cut by an unseen blade. And that severing isn't a sign of anything artificial. It's not technology, not propulsion, not intent. It's simply the solar wind changing direction. It's like watching a windsock whip around at an airport when a storm blows in. The tail follows the wind. The dust follows the light. They are worlds apart, yet tied to the same body, you know. And when Stefan, one of the researchers often quoted in discussions about comet behavior, explains this, he always emphasizes that whenever dust and gas exist near sunlight, plasma becomes inevitable. It's not rare, it's not suspicious, it's not out of the ordinary. It is the ordinary, but the ordinary becomes extraordinary when you can finally see it with your own eyes. And that's the wonder of it, because the comet isn't doing anything unusual by cosmic standards. It's doing what comets always do. But on Earth, in our late-night observatories and backyards, it feels like the comet is performing a strange dance just for us. Well, perhaps the most surprising part is how simple materials, rock, ice, dust, can produce shapes so complex they look like deliberate sculptures. A curl here, a kink there. A sudden twist, as if the tail were alive. But it's not alive. It's not aware. It's not intentional. It's just physics painting on a canvas big enough for planets and suns. We should pause on that idea. Because when we say the plasma tail points away from the sun, that's not just geometry. It's a story about particles being torn from their atoms and flung across the solar system. It's a story about invisible magnetic lines wrapping around them, pushing them, shaping them. It's a story about energy pouring outward from the sun every second of every day, sculpting everything it touches. So when you see a jet on the comet pointing toward the sun, it doesn't mean the comet is breaking the rules. It means the jet is coming from a patch of surface currently facing the sun. It means fresh ice is vaporizing directly under the heat, and the dust from that jet, once released, will soon bend away again. It's not a contradiction. It's a sequence, a rhythm, a process unfolding in time. And, the plasma tail bending or twisting is not evidence of control or engineering. It's simply the solar wind shifting its direction, often because the sun is restless. When a magnetic storm sweeps past the comet, it reshapes the tail in minutes. Minutes. Imagine that. A structure millions of kilometers long, reformed in less time than it takes to boil water. The beauty of this is that the strange shapes do not signal the unnatural. They signal the deeply natural, the profoundly natural, the cosmic scale of interactions we rarely get to witness. It's not alien, it's weather, space weather, solar weather, an invisible storm sweeping through a sea of charged dust. And when we think of weather on Earth, winds, tides, storms, we accept that these movements can be chaotic and elegant at the same time. The comet's tail obeys the same principle. It's just happening on a grander scale. Instead of air, we have plasma. Instead of gusts of wind, we have streams of solar particles. Instead of clouds, we have dust shedding from a relic of another star. And if you imagine standing close to the comet, somehow floating beside it, watching the tail stretch away behind you, you would see something astonishing. The dust tail would glow a soft gold, curving like a long road behind the nucleus. The plasma tail would be a blue spear, trembling, shaking, vibrating with the turbulence of magnetic fields. And the coma around you would be a mist, a fog, illuminated from within as sunlight tore particles apart. It's not out there alone. It's here, too, in us, in the way we react to beauty, in the way we interpret strangeness, in the way our minds search for meaning when confronted with movements we cannot predict. We grow older, clocks tick, and still we look for patterns in the sky as if they were messages. But they are not messages. They are memories of physics played out in the vacuum. And it makes you wonder, at least it makes me wonder if our fascination with these shapes comes from something older than science, something rooted in our ancient instinct to read the sky for signs, not just survival signs, but meaning, purpose, story. Well, perhaps that's why some people jump to extraordinary interpretations when the tale bends sharply. Perhaps that's why a plasma break feels uncanny to the untrained eye. When we see something strange, our first instinct might be to imagine intention. But intention belongs to minds, and the comet has no mind. It only has matter, energy, and sunlight. So, so what we're seeing in those strange amateur photographs and those blurry NASA frames is the same thing, a natural object being sculpted by forces so large, so invisible, so relentless that they feel almost supernatural. But they aren't. They're the same forces that shaped Earth, that shaped the sun, that shaped every star in the galaxy. And that realization brings us somewhere important. Because if the comet's behavior is misunderstood, and if its beauty is misread as mystery, then understanding the physics becomes an act of grounding ourselves, of seeing clearly, of letting science replace fear with awe, you know. And the more you look at the comet's behavior, the more you realize it's not trying to confuse us. It's showing us the universe's handwriting, messy, tangled, beautiful. A handwriting written not in ink, but in ionized gas, in dust, in magnetic storms. And that leads us to a deeper question, one that pulls us gently toward the next chapter. Because if everything we've seen so far, the plasma, the dust, the jets, is natural, then what exactly is 3I Atlas? What kind of object behaves like this? What kind of interstellar traveler carries these patterns, these ices, these strange chemical ratios? It makes you wonder, what lies within the nucleus itself, and whether this visitor is truly just a comet as we know it, or something older, colder, and far more unique than anything born under our sun. Well, stepping from that last thought about what might lie within the nucleus itself, you see, we now drift into the heart of the question that has followed 3I Atlas from the moment it appeared in our skies. Is it really just a comet? Or is it something stranger, something older, something that carries with it a memory from a star that no longer burns? And that question has echoed everywhere, from NASA's briefing rooms to late-night conversations among amateur observers staring at their screens in quiet disbelief. The fascinating thing is that when scientists first measured its composition, the basic ingredients looked familiar: water vapor, carbon dioxide, dust. The same essential toolkit of every comet born around our Sunday. And it would be tempting, so tempting, to say that this familiarity settles all doubts. But it doesn't. Not just because familiarity can mislead us, but because the details inside those familiar ingredients whisper a story that does not quite match the patterns we know. So let's start with the simple part. A typical comet in our solar system behaves in predictable ways. It outgasses when warmed, forms a coma, grows a tail, shows non-gravitational acceleration as jets push it subtly off course. 3I Atlas does all of that. It checks those boxes with ease, and that alone tells us something comforting. Whatever it is not a machine, not a probe, not a crafted artifact. Its movements, its shedding of gas, its ever-shifting coma arise from processes that don't need intention. They arise from heat and ice and sunlight, the oldest sculptors of cosmic behavior. But, then we encounter the numbers that truly matter, and in those numbers, something unusual appears. The ratio of carbon dioxide to water is significantly higher than most of our local comets. Not absurdly higher, not impossibly higher, but consistently higher in a way that pricks the curiosity. And, well, curiosity is the beginning of understanding, because when you see that ratio deviate, you can't help but wonder what kind of environment this ice was formed in. A colder birthplace? A region with more carbon-rich material? A disk around a star whose chemistry aged differently from our sun's? That is where the story begins to stretch beyond familiarity, you see. And when scientists studied the dust grains emitted from the nucleus, they found hints of an unusual nickel to iron balance. Again, not alien, not engineered, not a message, but a variation, a fingerprint of a stellar nursery that didn't match ours. And when you combine that with the object's enormous relative speed through our cosmic neighborhood, a new picture forms. A picture of an object that does not belong to our local stellar family, one that has been traveling for perhaps millions of years, perhaps longer, drifting between stars as casually as a seed floating between fields. It's not out there as an anomaly, it's out there as a relic. Well, perhaps the most poetic part of all this is that when NASA tries to assign a category to the object, the vocabulary almost feels inadequate. Comet, interstellar object, visitor, messenger. None of these labels capture the complexity of something that has crossed such distances, carrying the cold chemistry of a world that may have formed before Earth existed. And that is why defining it becomes so difficult. We only have 3 samples of interstellar objects: Oumuamua, Borisov, and now 3 IATLAS. 3. You cannot build an entire taxonomy of cosmic wanderers from 3 examples, the same way you cannot describe the diversity of trees by looking at a pine, a mango, and a single fallen branch. So we do what science always does in the face of limited information. We describe what we can, we compare what we see, and we accept that the categories may evolve. And that's the thing. Pluto was once a planet until we understood its neighborhood better. And 3i Atlas may one day belong to a new class entirely once we discover more objects like it. Perhaps we will call them fossil comets, perhaps ancient interstellar fragments, perhaps star debris, or perhaps simply travelers. Yet when the question arises, is this real? We return to something simpler, because real does not mean ordinary. Real does not mean familiar. Real means governed by the laws of physics rather than intention. Real means explained by chemistry and sunlight rather than design. And everything we have measured about 3i Atlas fits perfectly within that framework. No technosignatures, no engineered symmetry, no controlled rotation, just jets, ices, dust, and plasma behaving as they should. And the most extraordinary part might be this: the object's strangeness comes not from deviation but from origin. Its origin lies in a star system older than ours, a star system where the dust and the metals within that dust evolved differently, aged differently, cooled differently. Comets preserve chemical time capsules. They freeze the conditions of their birth worlds. And this one carries a chemistry that hints at a stellar environment our sun never experienced. So when we stare at it through NASA's instruments or through amateur telescopes in the crisp darkness of an autumn night, we are not seeing a mystery designed to confuse us. We are seeing the residue of a history long erased everywhere except in this one body drifting through our world. It is made of ancient memory, and what I find most humbling is that this visitor is not unique because of what it does, but because of where it came from. It reminds us that the galaxy is not empty, but full of debris, full of wandering relics shed by planetary systems throughout time, and each of those relics carries within it the frozen fingerprints of worlds we will never see. The, the question of definition becomes philosophical. Is this a comet? Yes, but not just a comet. Is it an interstellar object? Yes, but that phrase feels too clinical, too antiseptic for something that has traveled across the dark ocean between stars. It's not a ship, it's not a message. It's something older than either. It's a shard of a world, drifting without destination, carrying a record written in ice. And that ice is what makes the scientific evidence so compelling. The chemical makeup aligns with the expected physics of sublimation. The dust to gas ratios align with natural cometary activity. The non-gravitational acceleration matches jet outflow. No engines, no artificial thrust, just sunlight boiling ancient ices, just heat rearranging matter on a surface carved by time. We grow older, clocks tick, and still we cling to the wish that a mysterious visitor might be a sign of something more. But 3i Atlas reminds us that the universe does not need intention to astonish us. Nature alone is enough. Nature alone is profound. It leaves us with an unexpected kind of awe. The awe of realizing that the most extraordinary thing is not that the object is different, but that we caught it at all. That in the vastness of the galaxy, in the cold emptiness between stars, a fragment of a distant planetary system wandered close enough for us to see its tail, to smell its chemistry through spectra, to watch its jets flicker under the touch of sunlight. And that realization opens a doorway into a deeper mystery. Because if this object behaves like a comet, yet carries signatures unlike those born around our sun, then what else might be drifting through interstellar space? What other relics, what other fragments of lost worlds might be floating silently in the dark? Well, perhaps the more profound question is not whether 3i Atlas is real, but how many more are out there waiting to be discovered. And perhaps as we explore that thought, we begin to step into the next challenge, the next tension between what science can confirm and what imagination fills in when data falls silent. Because every time the sky goes quiet, every time an object slips beyond our field of view, something else happens. Rumors begin to bloom, speculations spread, and human wonder stumbles into shadowed territory. Well, you see, when the sky goes quiet and an object like 3i Atlas slips a little farther from our view, something very human begins to happen. And it's almost predictable, almost rhythmic, the way imagination rushes in to fill the silence that science leaves behind. Because where data pauses, stories begin. Where uncertainty widens, speculation slides in like mist. And that is not a flaw in us. It is a feature of being human. We live by stories, even while we chase truths. And in the weeks when NASA could not speak during that peculiar moment of shutdown, when the official voices were muted, people began writing their own explanations. Not just scientists, but everyone. People on social media, people who had seen only a few pictures, people who wanted something grander than ice and dust. And I suppose that's understandable. When a cosmic visitor from another star sweeps through our backyard, our minds leap to extraordinary possibilities. We imagine signals, we imagine craft, we imagine technology hidden in the tail's strange curvature. But, well, the truth is simpler and deeper. Humans hate an empty space in the narrative. When the facts pause, the imagination accelerates. And so rumors took shape. Some said the tail was too straight. Others said it bent too sharply. Others insisted the plasma looked engineered because they did not understand how magnetic fields carve shapes in charged matter. The sky became a canvas on which our hopes and fears painted themselves. And the internet amplified every brushstroke. You know how quickly a whisper becomes a chorus online. One person wonders aloud, what if it's artificial? Another repeats it. Another embellishes. Soon it's everywhere, stitched into threads, folded into videos, whispered in comment sections late at night. It's the oldest pattern in our storytelling instincts, dressed in the modern clothes of algorithms and feeds. So while NASA remained silent due to administrative locks, the world grew louder. That contrast, scientific silence and public noise, created a kind of storm. And when the storm grows, people feel pulled to choose sides. Either everything is mundane or everything is extraordinary. Either the object is a comet or it's a sign. But the universe rarely operates in such binaries. It's not one or the other. It's usually something in between. Natural phenomena that feel supernatural because we are not used to seeing them with such clarity. Well, the moment NASA returned to normal operations, they held a briefing. They spoke plainly, almost gently, explaining that 3I Atlas was behaving like a comet, with no technosignatures, no unnatural thrust, no anomalies that required anything beyond physics to interpret. And perhaps some people felt disappointed by that. Perhaps some hoped the universe had sent us a message instead of a relic. But science must follow evidence, not desire, you know? And that's where the process becomes beautiful in its own right. Because science does not silence imagination, it channels it. It turns speculation into hypotheses, hypotheses into experiments, experiments into knowledge. It treats every wild idea with the same opening courtesy. Prove yourself. And only those ideas that withstand the storm of data survive. That egalitarian beginning is something I've always admired. Every idea is born equal, but only some live long enough to become truth. So when people wondered whether 3I Atlas might be artificial, that question wasn't dismissed out of arrogance. It was tested, as all scientific ideas should be tested. And the tests returned nothing but natural behavior. Natural jets, natural spectra, natural acceleration. And once those answers took shape, the wildest rumors began to soften. They didn't vanish entirely, rumors rarely do, but science gave them boundaries. Science said, this is what we know, and this is what remains uncertain. And uncertainty, when properly framed, becomes curiosity rather than fear. So the real magic of this chapter is not in debunking anything, but in watching how science communicates with imagination, not just correcting it, but collaborating with it. NASA did not merely reassure people, they opened their data. They invited amateur observers, citizen scientists, and curious minds to look for themselves, to examine the spectra, to track the tail, to measure brightness curves. That openness is not accidental, it is essential. Well, because astronomy is one of the few sciences where anyone with a telescope or even a decent camera can contribute meaningfully. And in the case of 3I Atlas, citizen scientists provided real-time observations when NASA could not. They filled the temporal gaps. They tracked nightly changes. They captured tail disruptions after solar storms. And when NASA returned, they used those contributions to refine their models. It's not a top-down hierarchy. It's a network, a constellation of observers spread across Earth, attached by curiosity rather than authority. And this shared effort highlights something profound about how knowledge is actually built, slowly, collaboratively, with disagreements and course corrections, with both rigor and wonder. We grow older, clocks tick, but the machine of science keeps moving, powered by both professionals and enthusiasts. And yet, in the margins of this grand process, imagination keeps whispering. It says, what if? What if the next object is different? What if the next visitor shows a signature we cannot explain? Those whispers don't threaten science. They motivate it. They push us to observe more carefully, to question more deeply. And that tension between what is known and what could be gave rise to a new conversation. People began asking, if 3i Atlas isn't artificial, then what would count as evidence if we ever did encounter something artificial? What patterns would betray intent? What behaviors would break the symmetry of nature? These are not idle questions. They're future questions, questions that stretch beyond the specifics of this comet and into the broader landscape of our cosmic search. So in that sense, even rumors serve a purpose, not because they are correct, but because they highlight the boundaries of our understanding. They force scientists to explain not just the data, but the context, to say not only what something is, but why it is not something else. And the public, in its own chaotic way, helps shape that discourse, sometimes through misunderstanding, sometimes through curiosity, sometimes through fear, but always through engagement. And while this back and forth can be messy, it is also alive. It shows that people care about the cosmos, that they feel connected to it, that they react emotionally when a visitor from another star drifts near Earth. And that emotional connection is not trivial, it is the seed from which scientific interest grows. Well, and as NASA continues to refine their models of 3i Atlas, the rumors fade further. What remains are the questions worth keeping. How common are interstellar comets? How many more will pass through in our lifetime? What do their chemical signatures reveal about the diversity of planetary systems? Not just questions of what is real, but what is possible. Not just where this one came from, but what countless others might carry within them. And, well, that is where the future begins to widen in front of us, because this is only the third interstellar visitor we've seen, 3. When we reach 30 or 300, we may find patterns emerging. Some may resemble 3i Atlas, others may break rules we haven't imagined yet. And if that day comes, the question, is this real, will evolve. It will become something larger, something that asks about the architecture of the galaxy itself. We may find new classes of objects, new chemistries, new stories frozen in ice from stars long extinguished. And in those stories, we may discover echoes not of aliens or messages, but of the galaxy's own memory, written across billions of years. So as 3i Atlas drifts farther from view and the rumors settle into silence, we're left not with disappointment, but with anticipation. The sky hasn't closed, it has opened. It has shown us that the space between stars is not empty at all, but full of travelers, full of relics, full of quiet witnesses to cosmic history. And from that widening horizon, a final question begins to rise. If these relics are so full of ancient secrets, then what does 3i Atlas truly represent in the grand story of planetary systems? And what will we learn when we finally trace not just this one object, but the entire population of interstellar wanderers drifting through the deep, waiting for us to notice? Well, continuing from that widening horizon, you see, as soon as the rumors settle and the scientific explanations regain their quiet rhythm, something even more profound begins to surface. And it's almost as if the silence after the storm allows a deeper question to emerge, not just what 3i Atlas is, but what it means that such objects exist at all. Because once the noise fades Once the excitement softens, we're left with a truth that is far more magnificent than any conspiracy theory. These interstellar wanderers are not accidents, they are invitations. The realization that this is only the third object of its kind we've detected makes the galaxy feel strangely crowded. Not crowded with civilizations, not necessarily crowded with messages, but crowded with debris, crowded with fallen fragments of distant planetary systems, drifting through the dark like ancient seeds searching for a place to land. And when you think of it that way, 3i Atlas becomes not just a visitor, but part of a vast cosmic migration we've barely begun to understand. So chapter 6 in this story isn't really about the comet anymore. It's about us. It's about how humanity responds when the universe taps us on the shoulder and whispers in its slow, ancient voice, "There is more, so much more." And that whisper leads us toward a new frontier, not just observational, but philosophical. Because if interstellar objects are constantly passing through our solar system, even if most are too faint to notice, then the galaxy is sharing its history with us in real time. It's not a closed book. It's an ongoing conversation written in dust, in ice, in metal ratios that tell us what other stars were like billions of years ago. Well, the truth we often overlook is that our entire search for extraterrestrial knowledge, scientific or otherwise, doesn't begin with alien signals or megastructures. It begins with chemistry, with debris, with the leftovers of worlds. So 3i Atlas is part of a lineage that stretches across star systems, across epochs, across the quiet breathing of the galaxy itself. And that lineage forces us to reconsider how planetary systems live and die. Because if this comet truly carries ratios of carbon dioxide so different from our local comets, if the nickel to iron balance in its dust betrays a different style of stellar childhood, then what we're holding figuratively through spectra is a fossil from a world whose parent star may not even shine anymore, a ghost of a ghost, a relic of a system swallowed by time. It raises a haunting question. How many such fragments pass through the solar system every year without us noticing? So many objects must slip by, unseen, dark, cold, barely reflecting light, because our instruments weren't built to catch interstellar wanderers until recently. In the decades ahead, as telescopes improve and surveys expand, we might detect dozens, perhaps hundreds, and that will reshape our understanding of the galaxy. And as we step further into the 21st century, with surveys like the Vera C. Rubin Observatory preparing to scan the sky every few nights, we may finally begin to map these objects. Not just detect them, but categorize them, group them, compare their chemistries, build a library of interstellar relics. Imagine that, a cosmic museum filled not with artifacts made by civilizations, but with geological and chemical memories of worlds long vanished. And that leads to an astonishing possibility. If these objects differ chemically depending on the star systems they came from, then studying them becomes a way of studying exoplanets without ever visiting them, without needing a spacecraft to cross the gulf between stars. The relics come to us. They deliver themselves. They carry the icy signatures of their birthplaces frozen inside them. It's not out there beyond reach. It's drifting right through our night sky. Well, perhaps the most humbling part is that these objects show us something about our place in the galaxy. We grow older, clocks tick, and still we imagine our solar system as isolated, as if stars live in perfect solitude, each fenced off from the others like houses on distant hills. But the galaxy is not built that way. Planetary systems shed pieces of themselves all the time, Gravitational tides tug comets outward. Stellar encounters fling fragments into interstellar space. Over billions of years, the galaxy becomes a kind of ocean, with currents of debris moving from one system to another. 3I Atlas is part of that ocean. Borisov was another, Oumuamua was a third, and who knows how many more slip by in the dark. I suppose what makes this so moving is the idea that interstellar objects might one day help answer not just where planetary systems come from, but how planetary systems end. Because if 3I Atlas carries chemical ratios suggestive of an older stellar population, then it may have been ejected during the collapse of its system, or the red giant phase of its parent star, or even a close gravitational pass with another wandering world. And that makes every interstellar object a messenger, not of aliens, but of cosmic mortality, of the way stars age, of the way planets crumble, of the way entire systems shed their last fragments into the void. So when we analyze these objects, we're essentially studying the life cycle of planetary systems, their birth, their middle age, their death, and the remnants that survive all three. But, well, if this all sounds grand and distant, there is also something profoundly intimate about it. Because when you think about it deeply, when you let the idea settle behind your thoughts, you realize that the Earth itself may one day send its own fragments into the galaxy, pieces of our oceans, pieces of our crust, maybe even fossils, maybe even whispers of life. And billions of years from now, some distant civilization, or perhaps no civilization at all, may detect those fragments drifting through their skies and wonder, just as we wonder now, what story does this relic carry? That symmetry is beautiful, not just cosmic, but human. It reminds us that everything falls apart and drifts onward eventually. Stars collapse, planets fracture, civilizations fade, but fragments endure. And we've begun to imagine missions, interstellar interceptors that could chase down objects like 3I Atlas the next time one passes through. Missions designed not to speculate, not to fantasize, but to sample the chemistry directly, to land briefly or fly through the coma, to read the fossil record locked in the ice. A mission like that could change our understanding of exoplanetary science more than any telescope ever built. So chapter 6 becomes less about classification and more about possibility. The possibility that in the near future, perhaps by the year 2025 or perhaps later, we will have the technology ready to launch interceptors on short notice. The possibility that the next interstellar visitor will be studied up close. The possibility that we are about to enter a new era where the galaxy brings its secrets right to our doorstep. And, well, that possibility nudges us gently toward the final realization that the most extraordinary discovery is not that 3I Atlas is natural, but that it is part of a much larger pattern we have only begun to glimpse. We are standing at the threshold of a time when interstellar relics will no longer be rare, when they will no longer be mysteries we observe from afar. Instead, they will be samples of the galaxy's diversity, floating past us like messages written in ice. And the quiet question now rising on the horizon is this: if every interstellar fragment carries a story about where it came from, then what story does 3I Atlas leave behind as it drifts away? And what story will the next visitor bring, written not in rumor or imagination, but in the patient language of physics and time? Well, following that last quiet question about the story 3I Atlas leaves behind, you see, we now drift into the space where conclusions don't quite behave like conclusions at all. And that feels fitting, doesn't it? Because objects like this comet never really end anything. They pass through, they blur into memory, and they leave us with a trail of thoughts, still glowing, like dust lit by sunlight, long after the nucleus has vanished into the dark. So, so perhaps what we call an ending here is really just a slowing of the narrative, a moment to sit with everything we have learned and everything we still cannot grasp. And when I think of Three Eye Atlas now, fading back into the black ocean between stars, I can't help but picture those blurry images again, the ones that started all of this, the bad NASA images, the ones people mocked, doubted, questioned, the ones that look like nothing more than a pale smudge on a sensor. And I find it quietly poetic that those smudges turned out to be doorways. Doorways into chemistry, into plasma, into ancient stellar histories, into our own longing to understand the universe better than we currently do. That is the nature of science. It finds meaning not in perfection, but in persistence. Not just in what is visible, but in what can be measured behind the veil of the visible. Well, you see, the blurry images never lied. They simply asked us to look deeper. And in a way, so did the amateur images, those crisp, mesmerizing views shared night after night by people who simply loved the sky enough to wait for it. And together they gave us a complete picture, the beauty and the truth, the feeling and the physics. The universe never speaks in one voice. It speaks in harmony, sometimes discordant, sometimes subtle, but always layered with meaning. So in this quiet final stretch, let's return to a thought that slipped through earlier, that the comet was a visitor from a star older than ours. That realization alone transforms the way we see those faint, shaky pixels. Because when you understand that the light you're looking at reflects material older than Earth itself, older than the seas, older than the continents and forests and civilizations that rose and fell across our tiny world, you begin to feel something shift inside you. It's not awe alone, it's not fear, it's not curiosity, it's a blend of all three, a kind of reverent disorientation. And perhaps that is why these visitors unsettle us at first. They challenge the narrative that our solar system is the center of our understanding. They remind us that we are part of a far larger ecology, an ecology of stars, of debris, of memories, drifting silently across interstellar space. We are not alone in this cosmic ocean, not because of aliens or hidden signals, but because matter itself is shared, because fragments travel, because worlds crumble and their pieces wander. Well, and once that truth settles in, the question, is this real, becomes almost tender. That question isn't about doubting the comet anymore. It's about doubting our own understanding, our own readiness to see the universe as it truly is, rather than as a simple backdrop for human stories. It's not out there to deceive us. It's out there to humble us. We grow older, clocks tick, and still the universe remains older, stranger, more patient than we can ever be. And, well, when NASA stepped forward after the shutdown, holding their briefing, explaining the data in simple, measured sentences, it was a reminder that science is not a monument, but a practice, a conversation, a slow, careful stitching together of evidence until the picture becomes steady enough to trust. Their openness showing spectra, releasing models, encouraging citizen science was not just an act of transparency, but an act of respect, a reminder that knowledge belongs to everyone who seeks it in good faith. And meanwhile, the amateurs, with their telescopes buzzing in the cold, continued to capture the comet night after night, documenting its slow fading, its changing coma, its tail being pulled thinner and thinner as it receded from the Sunday. That persistence is part of the story too. Not just professionals looking downward from spacecraft, but ordinary people looking upward from backyards. And that parallel gaze is part of why this comet matters, not just because of what it tells us about interstellar chemistry, but because of what it tells us about ourselves. That we are still a species that looks up, that wonders, that asks questions, that doubts, that hopes, that argues and corrects itself and continues learning, even when the truth is complicated or quiet or hidden behind blurs on a screen. Well, in the end, 3I Atlas drifts farther away each night, shrinking into a point of light too faint for even the most determined observers. Its tail dissolves, its coma collapses back into a speck, and the object, once so alive with jets and plasma and controversy, slips over the horizon of memory. But the questions it raises do not fade with it, because now we know that these visitors are not rare. They are not once-in-a-lifetime miracles. They are the beginning of a new chapter in astronomy, an era where the galaxy itself sends samples directly into our neighborhood, where the relics of long-dead stars brush past our world in silence, where science becomes not just the study of our solar system, but the archaeology of countless others. So perhaps the most meaningful way to close this story is to imagine what comes next. Imagine future missions waiting in silence, ready to launch the moment another interstellar object is detected. Imagine interceptors weaving through a comet's coma, collecting dust from a star we will never see. Imagine laboratories on Earth holding grains of matter that formed in a system older and perhaps stranger than our own. That future is coming, gently, slowly, but inevitably. And as we step toward that future, we carry with us the quiet lessons of 3I Atlas. The lesson that blurry images can still reveal truths. The lesson that rumors are shadows cast by curiosity waiting for clarity. The lesson that science is not just certainty but humility. And the lesson that the universe speaks in fragments, and we must learn to read them with patience. And if you listen closely now, as the comet fades beyond the reach of our telescopes, you might hear a final echo, not a message, not a warning, but a quiet acknowledgement that we have only begun to understand the cosmos' vast tapestry, that each visitor is a thread, that each thread leads somewhere deeper, and that sense of continuation, of unfinished discovery, gently opens the door to whatever comes next, perhaps another faint smudge on the sky, another object slipping into view, another chance to ask once again, with wonder rather than fear, what story is drifting toward us across the dark this time?